Welcome to our video manual for the graphomate matrix. In the following minutes, I would like to give you a comprehensive insight into how you can work with this tool. The graphomate matrix is our powerful table component for SAP Analytics Cloud, PowerBI, Tableau, Microsoft 365, Lumira Designer and SAP UI5. It allows you to create IBCS-compliant tables quickly and easily. Using our own formatting language based on JavaScript, the so-called self-formatting language, we can carry out a wide range of conditional formatting. When developing the graphomate matrix, the focus was on performance, horizontal and vertical scrolling, hierarchical displays in rows and columns, as well as graphical visualization elements. As always, if we want to install a new widget in the SAC, we can do this via the Stories page. There we select the Custom Widgets tab, we then click on the small plus icon and navigate to the location where we have saved the file. From now on, we can use the custom widget. It has recently become possible to install custom widgets directly into the SAC. To do this, however, you also need a package with the resource files from us. To add the widget to the canvas, we need to select the graphomate matrix in the story under Add Custom Widgets. We then place the component at the desired position and size. We must then connect the data source. The dialog for this opens automatically. Here we can select any data source included in the SAC. In our case, I'm using an example dataset that was imported from a CSV file. Now we need to select the desired measures and dimensions from the data source. We drag the revenue and gross revenue as measures into the columns and the sales representatives and product groups into the rows. We also add the year dimension to the columns. As we can see, the matrix immediately creates a hierarchy from the different dimensions, both in the rows and the columns. Now I would like to give the component a title so that the viewer knows what data is displayed. To do this, I open the global settings using the Overlay UI, tick the Enable Title checkbox and enter the title in the field below. Multi-line titles are also possible. The lines can be formatted with HTML tags. We finish the entry with a click outside of the text field. 3 checkboxes offer us quick access to a crosstab view, moving the totals down, and to achieve a better readability of the table, we can activate an alternating background color of the rows. To make further adjustments, we need to open the GPS. To do this, we click on the gear icon in the Overlay UI. This opens the graphomate property sheet. Here we find extensive options for adapting the matrix to our needs. Let's start in the Data tab. To create a meaningful visualization, we usually need to display deviations, for example between the gross revenue and the revenue. We add these by clicking once in the Deviations field in the Calculations area or on the small plus icon on the right. This creates a deviation. However, we still need to define the measures or dimensions between which a deviation is to be calculated. To do this, we click on the object. In the dialog box, we can assign a name and select whether it should be an absolute or percentage deviation. I opt for an absolute. Then we have to select the target dimension and the corresponding elements of the calculation. To maintain an overview when using several deviations, it is advisable to assign a name here. If we want to calculate something other than a deviation of 2 dimensions, we use the calculated members. Create a new entry by clicking in the field. Clicking on the entry again opens the dialog box. The first step is to assign a name that will appear above the newly calculated column. Several steps are necessary to display the discount as a percentage. The elements of the calculation must be specified in a certain form so they can be processed correctly. In concrete terms, this means that we have to put the elements in curly brackets with a $ in front of them. Anyone who has experience with JavaScript will be familiar with this. We also need to make sure that the values are actually displayed as a percentage. To do this, we switch to the Labels tab, create a new value format, change it to %, and restrict it to the measured discount using the filter. With N+Rest, we can display a defined number of top or bottom members of a specific target dimension in our table and automatically summarize the rest. If we want to change the order of the data, we use the Sort Configurations function. First, we select the desired dimension which we'd like to resort. Once we've done this, the contained members are automatically displayed in a list. We can then rearrange them using drag and drop. Again, it would be useful to assign a name. Move Dimension Configurations gives us the option of swapping the components of a header hierarchy in their order or transferring them completely to another dimension. This function is more complex than it first appears. For example, we can use it to move columns to rows or vice versa. Now let's move on to the calculated aggregates. We create an aggregation and open the dialog. Here we assign a key and a name under which the aggregation is to be displayed or made available for other calculations. Then the target dimension is selected, in our case measures. Compared to the calculated members, we can select different types of data aggregation. We have the choice between sum, minimum and maximum value, count, which counts the number of members of the dimensions, and mean and geometrical mean. We can use the aggregation type to specify which aggregation the overall node should represent. This gives us the option of displaying the minimum value of a column at the top level, for example. This is particularly useful for large amounts of data per column. With additional access, we create the prerequisites for our in-cell Sparklines and Sparkbars. We will therefore come back to this later. The value filter does what the name says. For example, you can show only values greater than 300,000. However, the removed values also affect the totals calculation. This concludes the calculation section. The next topic is scenarios. We can specify these in the scenario definition section. The scenarios already set correspond to the IBCS rules. These scenarios influence all graphomate widgets on the dashboard and can be seen as a central control. Clicking on the scenario opens the dialog box. Here we can choose the scenario's color, the fill and, in case of a pin chart, the shape for the pin head, and which weighting the label should have. We can easily make these scenario definitions available to others via the string. We can now apply these scenarios in the scenario assignment area. Here again, an assignment is created by clicking in the line or on the plus icon. We then open the dialog to select which scenario is to be assigned and use the filter to restrict the assignment to a certain dimension. We can use the runtime data selection to control how we can select cells in the matrix. The none and single options are self-explanatory. In multi-mode, we can select several cells in succession by holding down the control key. The Cartesian mode allows us to span a selection also by holding down the control key. The last section in the Data tab, called SAC Data Binding, gives us the option of selecting either an SAC model or a shared data source as the source of our data. The latter is a small component which is available to our customers free of charge. It allows us to connect the data source once and distribute it to several widgets. The Measure Dimension in Rows checkbox is important if, for example, we have a hierarchy in our key figures and want to display this hierarchy in the rows. Let's move on to the Labels tab. There are two options in the title section under Visualization Comment that I would like to mention. If you are using our graphomate comments, you can control here whether a title comment displays an indicator on the title or the comment itself is displayed as the title. The Bind to Instance checkbox means that this comment is only visible on this instance. In the Value Format section, we can customize the display of the values. I would like to show you how we can implement the following example. The aim is to display the totals of the employees with 2 decimal places, while the remaining cells only show 1. We first open the existing number entry. Now we use the filter to determine which data should be formatted. To do this, we select the sales reps dimension with the corresponding members. We then set the decimal places to 2 and assign a name so that we can later recognize which configuration we are dealing with. Now we create a second object in which we leave the decimal place at 1. We use the filter to control that this configuration only affects the product groups, the objects on the second hierarchy level. Then we need another filter to restrict the influence to the necessary measures. Finally, we need to create a standard configuration and move it to the top in order to display the overall node again. The following settings are also available here. The locale dropdown provides the 3 most common display formats for numbers, which primarily influences how thousands and decimal places are separated and which abbreviations are used. We select the data type in the format type dropdown. By this, we make sure that time units, ordinal numbers and percentage values are also displayed correctly. Under abbreviations, we can influence how these are handled in the matrix. By default, a meaningful abbreviation is selected for each cell. However, it is also possible for this to be based on the smallest or largest values or on the mean value. Also, all numbers are displayed as multiples of 1000, 1 million or similar is possible. In this case, it may also be important to influence the number of the decimal places in the field below. If necessary, we also have the option of adding our own pre or suffixes to our values. We can determine how data with the value 0 is displayed, not to be confused with the subsequent option for empty data. The visualization of incorrect calculations can also be defined. Finally, we can choose between different rounding methods and define how negative values are displayed. Now we come to another powerful feature of our component. With scripted formatting, we can edit almost all of the component's parameters. To use a CFL rule, we create an object. In the corresponding dialog, we give the rule a name. The script body field will contain the actual script. Due to restrictions of the environment, the input field is not very handy for editing. Hence, we open the online editor via the link. Here we have implemented a collection of frequently requested scripts as templates. If we hover over the template, the corresponding script is displayed on the right. However, to be able to edit this, we must first click on the script. As already mentioned, the CFL is based on JavaScript, so if you know JavaScript, you should have no problem adapting these templates to your own requirements. As an example, I will now insert a traffic light into our matrix, which can be controlled via the threshold value. To do this, I copy the script into the script body field and confirm with OK. Of course, you can also create several of these rules and use them simultaneously or when required. In the next field, we can define variables, which we then use in the CFL script. How we use these can be seen, for example, in the CFL variables template. CSS is best suited for making simple, non-condition dependent changes to the display. The CSS script is inserted in the same way as before. The Hierarchy Nodes menu offers several functions which influence the appearance of hierarchies. In addition to the width of the indentation and the line spacing of the hierarchy nodes, we can also deactivate collapsing via checkboxes, and whether collapsing is done by clicking on the entire cell. The Axis tab gives us options for displaying the columns and rows of our matrix. We start with the column width. Here we first define the default state. The columns can automatically use the available space or be set to a specific pixel value. In the row below, we can set this for each column in the table. Here we have the choice between automatic width, an exact pixel value, or hiding the column. This is very useful if we need columns for calculating values, but do not actually want to see them. The column spacing can also be set. With suppress repeating headers, we avoid repetitions in the column headers. There are also some parameters for influencing the separator lines. Under rows, we find similar options. We can also use initial expand level to specify how far the hierarchy should be initially expanded, whether we want to have a changing row background, and whether the hierarchy should be displayed as a cross tab. The next tab, Chart Specific, contains the options for setting the in-cell charts. If we activate the deviation in the first tab, a bar chart object is automatically created here with the necessary filters and settings to visualize a deviation chart in the table. A click on the delta object shows us all the options. Scenario IDs for axes or bars can be assigned to these scenarios. To activate the comparison group, the same ID as in the other widgets must be entered here. This enables joint scaling between multiple matrices. We can also specify here whether we want to see the labels of our deviation, if negative values are evaluated as positive, and at which point the data is evaluated as an outlier. This is useful if we have individual values which deviate significantly from the norm. The settings in the pin chart and background bars assignment dialogs are almost identical. The background bars differ in that they only visualize absolute values, however, negative values can be drawn from right to left by activating the checkbox. Now we come to the special insert visualizations mentioned earlier, the Sparklines. As these are intended to represent a temporal progression, we need a corresponding dimension in our data feed. Therefore, we add the date dimension. To select the months from the hierarchy, we set the hierarchy level to 3. Now the turnover is broken down by month. Back in the property sheet, we click on Additional Axis in the first tab. Here we create a so-called hyperaxis. We give this dimension a name and select the date dimension as the basis. This makes the months disappear again. Back in the chart-specific tab, we create a Sparkline object and open the dialog. Now we select the month hyperaxis we have just created under Target Axis. As this is a hierarchy, we still need to activate Include Aggregates. Using filters, we can again restrict the columns or rows in which the Sparklines are to be displayed. Chart height defines the height of the Sparklines, and via curve type we can select if the lines are linear or smooth. We can implement Sparkbars or trend arrows in the same way, however, only one visualization per cell can be displayed at a time. Trend arrows have another special feature. As it is not possible to predict the scaling of your data, a so-called scaling factor must be adjusted. This allows us to influence the slope of the arrows in order to better show the differences. On the last tab, Input-Output, we find the input field to enter the URL of the graphomate server. Templates can be exchanged easily via this component. A template contains all settings of the GPS, excluding the data connection. This enables us to set up other tables with comparable data identically with a single click. If no server is available, templates can also be exported or imported. We have now reached the end of our video manual. If you have any further questions, please feel free to ask me in the comments or via email at info@graphomate.com.